Good afternoon, students. So before starting this session, we all are familiar with the electric things, right? Like a bulb, like an tube light, different motors, different all things. Okay, from which things they are working or which things they are depending. They are depending on the different electrical components, right? That we have to use to build that circuit to work or to perform perfectly or the correctly. Okay, so we all are familiar with the resistor, right? What is meant by the resistor? What are the resistor? What is the use of the resistor? Right, means what? Resistor. Resistor means it is a two-terminal electrical component that is used to transfer to adjust the level of the current or to stop the flow of the current. Means it manages the flowing of the current in the electrical circuits. Okay, it opposes the flow of the current in the correct way. If we have to say that, then the resistor is the two-terminal electrical component that opposes the electrical current that is flowing in the electric circuit. Or it can be used for to avoid the or to give the difference between the voltage also. Okay, so we all are familiar with the resistor. Let's look about the resistor, how it looks like. If I draw the resistor, it is the two-terminal resistor, right? One terminal and the second terminal. Okay, it consists of the different color bands. So its general diagram is the like this way. These are the color bands. This is called as the first digit. This is second digit. This is third digit, and the last one is called the tolerance. Tolerance. This is the symbolic representation of the symbolic diagram of the resistor, right? This what it consists of the different color bands. Like the first color band value is first digit, the second one is the second digit, third one is the third digit, and the last one is called the tolerance in that color band. So these colors are arranged in the different or in the specific manner. We have to write in the order in that way, like that. Okay. So what is the specific manner or what is the specific theme or the adjustment that we have to learn about that color is that the colors are arranging in such a way that it is look like an B. We have, for remembering, we have to shortcut, we have performed the different or so shortcut form, that is B, Roy, ROY, G, B, very good, 5. These are the short forms that we have to remember, the colors or the sequence of the color that we have to use or that we have to perform the values for the resistor to calculate the value of the resistor. Means the B, before it means the brown color. It means the brown. Second one is the black. Third one is the red. Fourth one is orange, yellow, green, blue, violet, grey, and last one is white. So these are the values that we have to perform. So what is the value for, if the color band is brown, then it has the value 1. After that it has the 2. After that it has 3, 4, 5, 6, 7, 8, 9 and 10. Like that way or similar this way, these colors are arranged in the specific manner and we have to calculate the value of the resistor or the color band of the resistor by using this manner. Okay. So these are about the colors. But what about, these are about these digits, okay? But what about the tolerance? Tolerance may be of black color, brown color, green, silver color also, and the gold color also. If the tolerance or the band is of the black color, then tolerance for that band is of plus minus 1 should be there. But if the tolerance is of gold color, then the tolerance is of plus minus 5% is there. And if the color band for the tolerance is the silver, then the tolerance for that color with respect to that color is plus minus 10, that we have to add it in that the color band sequence. Okay. So this is about the what we learn about the resistor. So what is the topic of today's our topic is that we have to learn about the arrangement of the resistor, means the resistors are arranged in the circuit in the series manner also, or in the combination, means the parallel manner also. So today we have to learn this arrangement of the resistor in the circuit about the series. So what is our today's topic is resistor in series. Okay, so today's topic is that we have to learn about the resistor that is connected in the series form. Okay, so let's see what is mean by the resistor series form. Okay, before that we have to draw this. So today's topic is the resistor about the which are connected in the series form. So what is the equation for that, and what are the different things that we have to perform in that. Before going to that, we have to draw the electrical circuit in which the resistors are connected in the series form. So let's draw this. Okay. Now I am going to draw this. I have three resistors. If I have three resistors, one resistor, second one resistor, and the third one resistor, all are connected in the series form. Series means in a straight manner, straight line direction. Okay, so I give the resistor, this is resistor R1, this resistor R2, this resistor R3. Okay, correct. After that I connect here one battery is there, minus plus battery, E charge is there, plus minus. Okay, after this battery I connected here one key is there, open key is there. So current flows in this direction. Okay, this direction. After this key I added here one current meter, ammeter, A plus minus, and after this one voltmeter is there, V. This is plus sign, minus sign, and it is connected in between this. This is the point terminal C, and this is the point terminal D. Okay, this is your electrical circuit diagram for the resistor connected in the series form. R1, R2, R3 are the resistance applied or connected in a series form. One battery is connected here, and one connected here, and the key is there. Means we will discuss it about the key. Okay, one current meter and the one voltmeter is given that. Now voltmeter V can be calculated I. So total current I is flowing through it. Okay, and the total current I is can manage or can give the potential difference between the point C and the point D, and the potential difference is represented by the letter V. It is the potential difference. It is the potential difference. It is the potential difference between the point C and D, and the R1, R2, R3 are the resistance, is the battery, is the current meter, V is the voltmeter. Okay. Now for that we have to perform we have to calculate the one equation for if the resistors are connected in the series form. Okay. Before that we will discuss what is meant by the voltage difference. Now potential difference. If the potential difference is different for the different resistors, the potential difference between the resistor connected resistor R1 is V1. Potential difference for resistance R2 is V2. Potential difference for the resistor R3 is V3. So all the potential difference is represented by depends on the resistors R1, R2 and R3, right? So the total potential difference is given by adding these three potential differences across this circuit, that is flowing through this circuit. So potential difference, total potential difference V is equals to V1 plus V2 plus V3. Okay, this is the total potential difference that this circuit have in that. Okay, after that, for this performance or for solving this equation, we have to use the Ohm's law. What is the Ohm's law? V is equals to IR, right? What is the Ohm's law? V is equals to IR, that is the potential difference. The current is the product of the current and the resistor, right? So, but here the resistors are not only one resistor is there, three resistors are there and that are connected in a series. So we can represent the R by RS, means total resistance is connected in series form. That's why I write here S. So RS is equals to R1, R2 and R3. Now according to this equation becomes V is equals to IRS, right? Means R means total resistors connected in the series form. Now for the resistor R1, V is potential difference is V1. For resistance R2, the potential difference is V2, and for the resistance R3, the potential difference is V3. Okay, so similar, by using that we get the equation or we get the form for potential for the resistor R1. V1 should be V1 is equals to IR1. Why? Because current flowing through whole circuit remains constant, but the resistors are different for the different potential differences. That's why for potential difference V1, resistance should be R1. So V1 is equals to IR1 according to this equation. This will be your first equation. Okay. After that, this is your star equation. After that, V2 is equals to what it becomes? IR2, right? For potential difference V3, it should be IR3, right? So these three equations we get from this. Okay. Now we get the value of V1, V2, V3. That means the potential difference of V1, potential difference of V2, potential difference V3 we get, and we have to put these values in equation star. So it becomes V is equals to I R1 plus I R2 plus I R3. But we put the values of V1, V2 and V3. But we also have the values for V also. So instead of writing V, we can write the value IRS. So instead of V, we will write IRS is equals to I R1 plus I R2 plus I R3. Right? So if we compare here, this side or left hand side of the equals to and the right hand side of equals to, I is common. If we take out the I common here I RS is equals to, if we take out I, it becomes R1 plus R2 plus R3. Okay, so this I is in multiplication form, then we can take from this side to this side, so it becomes I RS. This side of the equation equals to I is in multiplication, so after coming to this side it goes on in dividing form. So we get IRS upon I is equals to R1 plus R2 plus R3. This I and this I should be get cancel out, and we get the final value of the resistance connected in series is equals to R1 plus R2 plus R3. So this is the main general form, or this is the main equation when we have to use when the resistors are connected in the series form. So these are the equation that we have to use if the question is asked to find out the resistors value when the resistors are connected in the resistor form, series form. So we have to use this formula. Here the R1, R2 and R3 are having the different color bands value. So that we have to put here, and we can get the values when the resistors are connected in the series form. Okay. So in this way today we learn about the resistor connected in the series form. So what we study today, we study about the resistor. What is mean by the resistor? Resistor means it is the electrical two-terminal component that is used in the electrical circuit to oppose the current. It can be also used to avoid the voltage or to divide the voltage into different forms. Okay. After that, we draw the one circuit, that is the resistors connect in the series form R1, R2, R3, and the 1 voltmeter is there for positive and the negative sign, means what the V is the potential difference between that resistors. Okay. After this, we get the values of the potential difference V1, V2, V3. So the total potential difference that is in between this circuit is V1 plus V2 plus V3. So by using the Ohm's law, we get the value V is equals to IR. So after keeping the R is the total resistor, here the resistors are connected in the series form. That's why we get the symbol RS. So the equation becomes V is equals to IRS. And the values of V means the potential difference V1 for potential difference V1 and potential difference V2 and V3. Resistance remains current remains constant, but the resistance value is changing. That's why we get the value V1 is equals to IR1, V2 is equals to IR2, V3 is equals to IR3. After keeping this value in equation star, we get the value IRS is equals to I, R1, R2, R3. Here also I is there, and here also I is there. After getting common out in the I value, I will get cancel out and we get the value RS is equals to R1 plus R2 and plus R3. So this is the equation, or this is the form when the resistors are connected in the series form. You have to practice at home. Okay.